Hi everyone. Today we're going to derive some of the important things from the unit circle. And to derive something means to not just learn it, but actually see where it comes from. So what I've drawn right here is a very small graph. It's 1 unit in each direction. I stretched it out because I wanted some space for it. But basically, if you notice, I marked +1 and -1 in each direction. And the reason I did that is because the unit circle is a very small circle. It's a circle with radius 1, and usually what we do is we blow it up big because we want to study it very carefully, but I want you to realize it's actually a very small circle. The radius is 1. So I'm going to go ahead and draw the circle itself. And it won't be perfect, but that's okay. Oops, we do better than that. Okay, there is my unit circle, or my circle of radius 1. Now what I'm going to do is I'm going to pick a point somewhere on the unit circle. And that's going to be my generic point that stands for any point on the circle. And I'm going to call it x, y. Because it is generic, it can be any point on the circle. Now what we're going to do, we're going to use that point to create a right triangle by first connecting it straight down to the x-axis. That's our right angle. And then connecting it to the origin of the circle. That's our hypotenuse. Now if I think about this triangle for a second, the one thing that I know in the triangle, the hypotenuse that I just drew is the radius of the circle. And we said the radius is 1. So the length of that is 1. Now for the other two sides, we actually don't know what their length are because we don't know what that point x, y is. But the letters x and y actually give us the sides. Because if you think about it, when you're plotting a point, what you're doing is you're saying, I'm going to start at the center. If the point is 2, 5, you're going over 2 and up 5. So if that point is x, y, what that means is I've gone over x, that would be the bottom of the triangle, and up y, that would be the right side of the triangle. So we have a right triangle where the three sides are 1 for the hypotenuse, x for that horizontal side, and y for the vertical side. Now the other thing I want to do is label theta, because we have an angle right here that's drawn in perfect standard position. It started at 0, a perfectly horizontal line pointing to the right, and it's measuring counterclockwise from there. So we have our triangle, we have it labeled. What I want to do next is see what happens when we apply SOHCAHTOA. SOHCAHTOA is our main trig tool. So in order to do that, I want to label the sides, opposite, adjacent, and hypotenuse. The 1 is definitely the hypotenuse. We notice that right away because it's opposite the right angle. Now as soon as I labeled theta as that bottom left angle, that makes y opposite because it's opposite from theta, and that makes x adjacent because it's adjacent to theta. So now I can do SOHCAHTOA. So let's start with the first one, SOH. I'm going to set up a ratio for sine of theta. Now, sine of theta equals from SOHCAHTOA, opposite over hypotenuse. In our triangle, opposite is y, and hypotenuse is 1. Now, y over 1 is just y. So basically what we've just learned is that in this triangle, y equals sine theta. Now, y represents two things. It represents the vertical side of the triangle. So now all of a sudden this y right here is sine theta. But probably more importantly, it represents the y component of our point. Now let's try the same thing with cosine. So I'm going to use SOHCAHTOA to set up an equation for cosine of theta. Now CAH, cosine is adjacent over hypotenuse, and in our triangle, adjacent is x, hypotenuse is 1. And we get almost the same thing happening. X over 1 is basically x, so what we've just learned is that x equals cosine theta. Now x is two things in this picture. It's the horizontal side of the triangle, but more importantly, it's that x value of our point right there. So you may have learned before, I don't think this is for most of you the first time you've learned unit circle, but you may have learned that every point on the circle represents cosine theta, comma, sine theta, for the angle that you use to find that point. And now you know why. It all comes directly from SOHCAHTOA and realizing that the hypotenuse is 1. Now, while we have this picture on the board, I want to go over a couple more things. A lot of times people think the unit circle is just something to memorize, like, okay, there's a 30 degree, a 45 degree, a 60 degree, or pi over 6, pi over 4, pi over 3, and that's it. I'm just going to memorize the numbers. This one's root 2 over 2, this one's root 3 over 2, this one's 1/2, but it doesn't have to be. I mean, this works for anything. So if I make up an angle, let's say I drew an 80 degree angle in here, which is definitely not a unit circle angle. 80 would be a little bit short of 90. It might be about there. So let's say I just drew an 80 degree angle. Now 80 is not really a unit circle angle, but if I know what this point is right here, it's going to tell me what cosine and sine of 80 are. So if you look at your circle, now I spaced it out so that on my graph paper, every 5 squares counts as 1 unit. So what I'm seeing right here is for the x value of this one, it's like 1 square over. That would be about 0.2. For the y value, it's almost all the way to the top. It's going to be like 0.9 or more, 0.95 maybe. And now, all of a sudden, we have approximates for cosine of 80 and sine of 80. So if you didn't have a calculator on you and somebody asked you what's cosine of 80, from the unit circle, it's probably somewhere around 0.2. And if somebody asked you what is sine of 80 degrees without using a calculator, it's pretty close to 1. It's going to be high, 0.95, around there. So don't think of the unit circle as just something to memorize. Think of it as something to understand and use. Now the last thing I want to do before we wrap things up is we did ca. Let's see what happens if we do tangent. So if I do tangent theta, going back to my triangle again, tangent is opposite over adjacent. Now from our triangle, that would be y over x. But we just figured out these have other values. Y is sine theta, x is cosine theta, and there's another thing you've learned before. I know that most of you knew that tangent is sine over cosine, but now you can see why. That comes from the unit circle as well, or from SOHCAHTOA. So this was just a basic introduction. This is not as much the work you're going to be doing in class, but this is just to understand where it all comes from.